All right. So 7.8, number 5. So Jordan, I think, said that he didn't have any problems doing the integration when taking the integrals, right? But where he gets stuck is actually finding out what the limit is. Okay. So then first of all, looking at this integral, and by the way, that should be a minus sign. I wrote it down as plus originally. But looking at this integral, we're going to have problems whenever the denominator is 0. Now, when does that happen? That happens when x is 1 or when x is negative 1. But neither of those numbers are within the limits of integration. So we don't have any problems with improper integrals in that sense. What we do have a problem with is this upper limit of integration being positive infinity. So we take care of that by letting that upper limit be k, and then taking the limit as k goes to infinity. Now, as far as integrating this thing is concerned, I used partial fractions, right? So I wrote this denominator as x plus 1 times x minus 1, and then used partial fractions to solve it. This is what you end up with when you do that. Okay? So now let's take the limit of this thing. So this is going to be limit as k goes to positive infinity of ln of k minus 1 minus ln of k plus 1. So it's that minus, if we pop in the 3, it's going to be ln of 2 minus ln of 4. Okay. Whoop, I went off the screen there. I apologize. Now, if you imagine popping in infinity now, right? This is going to be infinity minus infinity, which is indeterminate. The good news is that these are natural logs, and so you can rewrite this using the quotient rule for logarithms. Okay? And when you do that, you get ln of k minus 1 over k plus 1. This part, notice that 4 is 2 squared, and 2 squared I can write as, or ln of 2 squared I can write as 2 times the ln of 2. So this is really ln of 2 minus 2 times the ln of 2. That's just a negative ln of 2. Negative ln of 2 with that negative will actually make it a positive ln of 2. Okay? So I've taken care of that business. Now, limit as k goes to infinity. Here we have two polynomials. You can move the limit inside of the natural log, right? Okay, so we're really just looking at the limit of this thing. What's the limit of this thing? Well, it's two polynomials, so the limit's going to be the ratio of the leading coefficients. Or if you like, you could use L'Hopital's rule and take the derivative of both. You're going to get 1 over 1. In either case, right, the limit as k goes to infinity of this expression is 1. So this is really ln of 1 plus ln of 2. ln of 1 is just 0, right? So ln of 2 should be your final answer. I didn't check the answer on that, so I hope that's correct, but I think that should be right. Okay, so ln of 2 on number 5.